All right, we're going to keep on moving, and we're going to find the area of the third and final region between these two curves. We're going to call it region C. It says it's in quadrant 1, and it's bounded above by y equals 4x minus x squared, and below, right, because it didn't label it again for me, but this graph is the 4x minus x squared. All right, and so that's what it's bounded above by, but then it's bounded below by the graphs of y equals 4 minus x squared and the x-axis. So we're talking about this region right here. So it's very, very important that you, again, I cannot say that enough, read carefully to figure out what region you're going to be finding the area of. Okay, so now I want to know what interval of x values defines this region. So I want to go to the furthest to the left point that is part of this region, and I need the x value there. Well, remember, we found that ordered pair to be 1, 3, so that interval starts at 1. All right, and then during all this space here, we're going all the way to the furthest x value to the right, which is where this graph intersects the x-axis, which happens to be clearly labeled at 4. But if it wasn't clearly labeled at 4, you may have to find that on your own by setting that equation equal to 0, that function equal to 0, and literally solving for x. And that would actually require us to factor out an x, and then x equals 0 and 4. Here's the 0 intersection point. Here's the 4 intersection point. Okay, so sometimes you will have to do that part on your own. All right, so this region goes all the way from x equals 1 right here, all the way over to x equals 4. Okay, now the next part says, thinking about dividing this region up into rectangles, would the height of each rectangle be calculated using the same rule? Okay, so when I go, what they mean is when I go to draw my representative, what did we call it in the last one? Just like a strip. When we go to draw our representative strip, all right, to be our thin rectangle, like the idea is no matter where you draw it, okay, would the height, or would the way we calculate the height be done exactly the same? Okay, and so you need to think about that for a minute. If I drew my thin strip here, okay, then I would be touching both curves, right? The 4x minus x squared and the 4 minus x squared. But if I drew it over here, okay, all right, then I would not be touching the 4 minus x squared at all. I'd just be touching the top and the x-axis. Okay, and so the way we calculate the height is not going to be the same for that entire region. Okay, and so what we have to do is we have to figure out where are we going to have to break this up, right, so that we can calculate the lengths and widths appropriately. All right, and so that ends up being question 28, I believe. It says divide the region C into 2 regions so that the height of each rectangle in that particular region is calculated using the same curves. All right, and so when you look at the picture, all right, the idea is like, okay, this curve, this particular curve, the bottom, when I draw my length, the bottom of this first section will end, all right, when I get to x equals 2. Okay, so that's where I can break up my interval. So I'm going to have to have one set of lengths that go from 1 to 2 and a different set of lengths that go from 2 to 4. Okay, and so that's what question 28 is asking. What are the x values of those 2 regions? So I've got to have one region that goes from 1 to 2 and another region that goes from 2 to 4. Those are my x values. All right, which means I'm going to have 2 very different integrals, and then I'm going to add them together. So it literally says write and evaluate a definite integral for each region, okay? So I need an integral that goes from 1 to 2, and I need an integral that goes from 2 to 4. All right, and remember, I need the area of that representative strip, which is length times width. Width is just your dx. All right, so the length of the first strip here, all right, the length of the first strip is going to be the top function, 4x minus x squared, minus the bottom function. Make sure you use parentheses on that bottom function. All right, and then that's the length, and I still have to multiply that by the width. Okay, and then when I do the second region, all right, and the length is the top minus the bottom, but this time the bottom is 0. Okay, so the top, I just have to know which curve it's on, and it's on the 4x minus x squared curve. And if you want to actually write minus 0, just so you understand the concept, it's always top minus bottom. All right, then we're going to multiply by dx there for the width as well. Now, remember, we have those things typed in our calculator, so if you remember which is which, as long as you do it right, you can literally refer to them as y1 and y2. But please, please, please remember that we called that I called 4x minus x squared my y1, and then the 4 minus x squared was my y2. So if I'm going to use my calculator to work out that first integral, okay, then I am going to do math 9. I'm going to start at 1. I'm going to go to 2, and I'm going to have to put in y1 first. Sorry about my dog barking right there. So y1 minus y2. I really like doing it this way though, because it avoids any accidental subtracting and not distributing, etc. I mean, you're more than welcome to simplify that before you actually type it in, but you can let the calculator do all that work as well. And then of course you need an x there, and that one comes out to be exactly 2. All right, and then I'm going to work out the second integral on my calculator as well. I'm going to go from 2 to 4, and since I'm only using the 4x minus x squared, I only need y1. All right, you're welcome to put minus 0, but of course you know that doesn't change the value. And then we're going to hit dx, and just to make it perfect, math enter. All right, so that area is 16/3, and so then what is the value of the area of the entire region? Well, then you have to add those two areas, and let's see, that's going to be 22/3. Okay. All right, and so that video obviously is a lot shorter because hopefully we're getting the hang of it. You're finding area, but you have to find a length, which is the top curve minus the bottom curve. If you draw that representative strip in more than one place and you don't have the same length the whole time, then you are going to have to break up your integral and then eventually add them together. Okay? And so that concludes the video on region C. And in the next one, I'm actually changing the curves completely. It says find that region, the area of region A, but we're going to change it to D so that I can label my video appropriately. Okay, so that was region C, and I'm going to do another video for region D.